So just to recap back on what you did in the lesson last time, because I didn't really get to go through this question with you. Basically, this question talks about a lot of things that you probably are not familiar with, things like polarized light, optical rotation, and whatnot. But the main point that you need to get out of this whole paragraph is that alpha minus alpha final is your concentration. Okay, so this is what I want you to focus on. The concentration of sucrose is alpha minus alpha final. And then, hello? Okay. Can you hear me?
Yes.
Okay, sorry about that. I got disconnected. Okay, so then the expression is this form. Okay, log alpha minus alpha final is actually your y-axis. Okay, and then your x-axis is t. Okay, so that's your x-axis, right? That means A in this case, hold on, how do I? Okay, so A here is your y-intercept, or what we call C. Okay, I'm just gonna write down that. And that leaves you with the negative k over 230. Okay, so that is your gradient. So I'll use a different color. This part, sorry, draw. Negative k over 230, that's your gradient. Okay, right. Clear. Then they ask you to plot the graph, and your graph should be a straight line, a decreasing straight line going down. Okay, I think most of you have done that. Your gradient is a negative number, okay, evidently from your the line that you have drawn. But your k, in this case, the value for k must be a positive number. Okay, so make sure you got that as well. Right, the second part, part D, is the concentration of sucrose. Same thing, on the y-axis is the concentration of sucrose over time. Okay, same reaction, except that the reaction is carried out at a different temperature. At the moment, we do not know yet if it's higher temperature or lower temperature. Okay, so concentration time graph, when you see a curve, it is definitely not zero order. It would be either first order or second order. But in the first part of the question, already it says somewhere that it is first order. I thought, yeah, this one. The reaction can be considered to be first order with respect to the sucrose concentration. Okay, so you already know that this reaction is first order. Okay, so the point at time t is equals to 200 seconds. So it is referring to this point. Okay, so you can see that that point is the concentration is higher than it should be. Okay, the concentration is still high. Therefore, they want you to suggest what can be used to explain. Okay, can you hear my voice?
Yes.
Okay. Yeah. All right. So we need to come up with a reason as to why this point is higher than it should be. Okay, now concentration, you cannot really comment anything about the concentration because you use a polarimeter. What do they use? Polarimeter, yeah. It is, the reaction is monitored using a polarimeter. So a polarimeter is a machine, okay? So it's a computer. So you would expect computer to be, would be great at reading concentration. Okay, so the only reason that can be we use to explain why the concentration is higher than that at that particular time could be an error on our part. Okay, so what is a possible error on our part? That it is, well, maybe we have taken the concentration was taken at an earlier time. Okay, maybe, you know, for whatever reason, we are not accurately reading the concentration at T equals to 2000. Okay, maybe it was at T equals to 1800, maybe. Okay, because you can see that that point is there, right? So there's nothing wrong with the polarimeter because it is computer, right? We cannot put the blame on the computer. So the only error that we can think of is our human error. Okay. Okay. I hope you got that. Okay, so please, I'm going to clear it. Moving on. Use the graph to determine the half-life of T half of this reaction. State the coordinates of both points used in your calculation. Okay, T half-life or T half is the time taken for the concentration to drop by half. Okay, so the first coordinate that you should take is this one. That's your starting point. Of course, you would take that. Read that point, the x-axis and the y-axis, that's 0, 44, I think, if I'm not mistaken. Okay, so half of 44 is 22, which is somewhere here. Okay, so they want the concentration to go down by half, and more specifically, you have to read the concentration. Okay, so you read the time when, oh, you read the time when the concentration is, oh my God, what's happening here? Hold on. Okay. So I cannot move my graph, otherwise everything will be adjusted. Okay, so please read the time taken from that point. Yeah. So what do they want you to find? They just need one half-life, right? Yeah. Okay, so you just need this section. Must read the time, not the concentration, not anything else. Okay, so that time taken for the concentration of sucrose to go from 44 to 22 is called the half-life. Okay, can you please read your own graph for that? Sorry. Sorry. Okay, so for those of you who just joined us, Hamida and Sabrina, we're just finding the half-life from the graph. Okay, basically, as I mentioned just now, the half-life is the time taken for the concentration to go down from 44 down to 22. Okay, so the half-life, you must read the time, which is the x-axis. Okay, so I repeat, for the concentration to start from 44 to go down to 22. Okay, so you draw a line here at the 22, and then you read the time taken. Okay. After you found the half-life, can I know what sort of number you are getting for the half-life? You can give me the answer in the chat. Because yeah, I'm not calculating, so I am expecting your answers. Sorry. Once you get the half-life, can you please let me know? Hi, Shakirin. You're just joining us, so I'm going to repeat again what I just said. We are now looking at part 2 of question 2 on page 12, basically finding the half-life. Half-life is the time taken for the concentration to go down by half, okay? So you start with this point here, okay? And then you go down to half of that, which is 22. So this is your second point, okay? So you have to read the time, right? That's not a straight line, but you get the drift, okay? So that's the time taken or for the concentration to go down by half, which is T half. Right, any answers? 660. Okay, so you only need one half-life, okay? That's why they ask you for 2 coordinates, but if you want to make sure that they are constant, knowing that it's a first order and you want to check that is the half-life constant. So Safina got her half-life as 660. How about the rest of you? Are you getting around that value?
Yes.
Okay, right. So now that you know the half-life, you are given an expression again. For a first order reaction, the following relationship exists. Okay, so half-life is 660, as you all have calculated. And then you are expected to find K1, okay? I'll call this K1. The reason why they call it K1 is because if you remember in the previous page here, for the first part of the experiment, there is also a rate constant, but it's K, okay? Just K. So there are two different experiments at 2 different temperatures, and therefore they have K and K1, okay? So calculate your K1, 0.693 divided by 660. Can someone give me their answer for K in the first part? This one. The K in this expression. Can you give me the answer? So experiment 1, K is equals to, anyone, please? From the first part, is it? Or is that the second one? Experiment 2 is K1 is equals to, Safina, is your answer 4K from the first experiment or the second experiment? Second. Okay. So what's the first experiment? What's your K from the first experiment? Okay. That seems better. Okay, so I'll cancel that. Ignore that number. So the K from the first experiment is 7.08 times 10 to the power of minus 4. So you can see that in the first experiment, your K is a much smaller number. In your second experiment, your K is a bigger number, okay? So what they're asking is now, using, state whether the temperature of the second reaction was higher or lower than that of the first. Okay, now, if the rate constant is higher, then obviously the temperature is higher, okay? If you remember, rate constant is only affected by a change in temperature. Rate constant is not affected by the change in concentration, not affected by the change in pressure or anything, but change in temperature, okay? So the higher the K, the higher the temperature is, right? So to answer this, state whether the temperature of the second reaction is higher. Explain your answer. Because higher rate constant K1 in the second reaction. Here we can see that. Oh gosh, there it goes. I've accidentally deleted it. Okay. Oops. Never mind, I'll just leave it there then. Okay, what would the value of the half-life change if the reaction were repeated with twice the initial concentration of sucrose? Now, one thing that you need to remember about the half-life of a first order reaction is that it is constant. Half-life will not change. Okay, so the answer is no. The half-life will stay constant because it is a first order reaction. Okay. Right. So basically that is it. Okay. The reason why I want to discuss this is because I don't want to leave this unexplained for you. Okay. I know it's a bit of a rush. Some of you are going in and out and with the connection, but I'll upload this recording on YouTube. Okay, so let me just stop first.